prime numbers have counting number factors of 1 in themselves. So for instance, 3 has just the factors 1 and 3. You could write it 3 and 1, or 1 and 3. 5 has only the factors of 1 and 5, or 5 and 1, same thing. 7 has the factors 1 and 7, or 7 and 1. But you might ask, what are counting numbers? Well, counting numbers are just the numbers that we count with. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. It carries on. So when we're talking about prime numbers, they have counting number factors, so they would be numbers that we can count like this, that have factors of 1 in itself. In this case, 8 is not prime because you can rebuild it like that. You could build it with 2s if you wanted, but you would end up with so here you could count by 4s, or you could count by 2s, but these are exactly the same. You can see by putting them one on top of the other. Okay, but it's clear that 8's not prime because it has more than 1 in itself as factors. It also has 4 and 2. Okay, so the prime counting numbers that are on the table would be 3, 5, 7, and then 8 is not prime. I don't know why I took that off there. Oh, and 2, sorry. These are not prime because we can reshape them. We don't consider 1 prime because its factors are just 1 times 1, whereas this has 1 times 2, 1 times 3, 1 times 5, 1 times 7. Okay, so prime numbers, non-prime numbers, and keep in mind that it goes on and on all the way to infinity. So let's just pick a number. Let's pick the number 8, and let's prime factor it. Well, we would start with doing it with an over distance of 1 and then an up distance of itself. And then what we would do is we would look at that up distance and say, can we take that up distance and reshape that? And instead of it being 1, 2, 3, 4, 5, 6, 7, 8 all in a row, can we reshape it as a different kind of rectangle? And yes, we can. We can reshape it as 2 across and 4 up. We could do 4 across and 2 up, but what I like to do is put the smallest number on the over distance when we're doing prime factoring, because you'll be able to just follow it along like this and you'll see your prime factors. 4 is the up distance here. Can we prime factor that? Or sorry, can we factor that anymore? Yes, we can. 2 across and 2 up. Okay. If you look at our if we look at the numbers that would go here, we have a 1 here, so we don't include that. We have a 2 here, we have a 2 here, and we have a 2 here. And we can't factor 2 anymore because it's prime. So our prime factors of 8 are 2 times 2 times 2. And if we check that, we can see that this says 2 2's, 2 taken 2 times, and this tells us that we need 2 of those 2's taken 2 times. And can you see how that's the same as 8? 2, 4, 6, 8, or you could do 4, 8. You could count by 1's too if need be. 1, 2, 3, 4, 5, 6, 7, 8. Let's prime factor the number 12. Again, we go 1 across and 12 up. 12 can be reshaped. We can make that 2 across and 6 up. 6, this side here can be reshaped. It can be 2 across and 3 up. 2 across and 3 up. 3 is prime, as we talked about earlier. And that's it, we're done. We cannot reshape 3. So we don't include the 1, we don't include the 12, because 1 is not prime, and 12 can be reshaped this way. We include the 2. We don't include the 6 because 6 can be reshaped this way, and we include the 3. So our prime factors are 2, 2, and 3. So 12 prime factored is 2 times 2 times 3. If you look at this, this says that we have 2 taken 2 times. 2 taken 2 times, and it says we need 3 of those. 3. So 2, 4, 6, 8, 10, 12, or 4, 8, 12. If you wanted to put it this way, you could count 6, 12, but we can see that 2 times 2 times 3 is going to be the same as 12. All right, let's prime factor the number 16. Okay, Again, we go 1 across and 16 up. 1 is not considered prime, and it also cannot be reshaped any more than it is. But 16 can. We could do 2 times 8. Sorry, 2 across and 8 up. Okay, can we reshape 8? Well, yes, we can. We can reshape 8 as 2 across and 4 up. Can we reshape 4? Absolutely. 4 can be reshaped as 2 across and 2 up. So when we're looking for our primes here, we ignore the 1, we ignore the 16. 1 is not prime, and 16 can be reshaped. We're looking at the 2 here because it is prime. 8's reshaped, so we're not looking at 8. We're looking at this 2, and that is 4. We're not looking at that because it can be reshaped, so we're looking at this 2, and we're looking here. I don't know if you've noticed, but if you skip the 1 and go all the way through like this, you end up with your primes like this. So 16 written as a product of primes is 2 times 2 times 2 times 2. And if we were to work that out, we would have, it says 2 taken 2 times, and it says we need 2 of those. And then it says that we need 2 more of all of that. So there's 2 of them. There's 1, 2. So first we have 2 taken 2 times, 2 times 2, and then times 2, and then times 2. And that gives us 4, 8, 12, 16. Let's prime factor the number 20. So again, 1 across and 20 up. 1's not considered prime, so we're not looking at that, but we are looking at this to see if we can, and you can't reshape 1. This is the only shape that you can get for 1. So let's reshape 20. Let's do it 2 across and 10 up. Can we reshape 10? Well, yes, we can. We can reshape it 2 across and 5 up. 5, can you reshape? No, 5 is, that's the only way you can reshape 5. I mean, you could do it this way, but it's the same shape. So we consider 5 prime. So we don't look at the 1, and we don't look at the 20, because 1 is not prime and 20 can be reshaped. We look at the 2 because it is prime. We don't look at the 10 because it can be reshaped, but we look at this 2 because it's prime, and then the 5 is also prime. It cannot be reshaped. So 20 written as a product of primes is 2 times 2 times 5. And again, if we want to work it out, this says 2 taken 2 times, and it says that we need 5 of those. So there's 2, 3, 4, 5. And if we count, we got 4, 8, 12, 16, 20. Or we could put them like this, and we could count 10, 20. Or we could go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Or if need be, even count by 1s all the way to 20. Let's prime factor 18. Again, we reshape it so it's got a distance of 1 over and 18 up. 18 can be rewritten as 2 across and 9 up. We could easily build that out of 2's if we wanted to, but I chose to do 9's because it's faster. But kids can also use 2's if they wanted to. So they can either choose to do it this way or this way. Either is fine. What we're counting is 2's, and we're counting 9 of them. Can 9 be reshaped? Yes, it can. So we reshape it. Can 3 be reshaped? No, it can't. The only way to get 3 is this, and we've already got that right there. So again, we don't look at the 1 because it's not considered prime, and the 18 can be reshaped into this. We look at the 2 because it is prime. 9 we don't look at because it can be reshaped into this. 3 is prime. 3 is prime. So our factors, our prime factors of 18 are 2 times 3 times 3. Let's prime factor the number 9. And again, we do 1 across and 9 up. And then we look at this side here. Are we able to reshape the number 9? Yes, we are. We can reshape it 3 across and 3 up. 3 on this side here is prime, so we can't reshape it anymore. So our prime factors do not include the 1. They don't include the 9 on that side because 9 was reshaped to this, but they do include this 3 and this 3. So our prime factors of 9 are just 3 times 3. Let's prime factor the number 10. So let's start by putting it 1 across and 10 up. Can we reshape 10? Sure we can. We can do it 2 across and 5 up. Can we reshape 5? No, because 5 is prime. So again, we're going to look at our factors. We've got 1 and 10 for this one. We've got 2 and 5 for this one. We don't consider 1 to be prime, and 10 obviously is not prime because we can reshape it. So we're going to look at this one here, which is 2, and we've got 5 here. 5 is prime, so we can't reshape it anymore. So our prime factors of 10 are just 2 and 5.